Bismillahirrahmanirrahim. Assalamu alaikum everyone. Welcome to my channel, The Baloch Scholar. So today I'm starting another topic of chapter number 3, Kinematics, that is motion graphs. Okay. Today I'm going to teach you the motion graphs. So what is the motion graph? The distance time graphs and speed time graphs are referred as motion graph. So here we will deal with the distance time graphs and speed time graphs. Okay. First of all, I will deal with the distance time graph, then speed time graph. Okay. As you know, distance over time is speed. Okay. Distance over time is speed. So let's come towards the distance time graph. Okay, distance time graph. Distance time graph represents the motion of objects using graph. Okay, you can represent the motion of the objects by using the graphs. Okay, so in distance time graphs, time is taken along x-axis and the distance is taken along y-axis. Okay, suppose this is a graph. This is the graph. Okay, so this is x-axis, our time, and this is the distance. Okay, this is y-axis. Means an distance time graph, time is taken along x-axis and distance is taken along y-axis. Okay, see here, this is the graph. Here it is the y-axis, that is distance, and it is x-axis, that is time. Okay. Okay, now let's discuss the cases of motion graph. The first case is the object is at rest. Okay, suppose if an object is at rest, so how we will draw its graph. Okay, when an object is at rest, then the distance covered by the object is 0. Means if it is saying that if the object is at rest, then the distance covered is 0. If the object is at rest, it does not cover any distance, but time is continued. Okay, time cannot be at rest. Okay, the distance moved by the object with time is 0. Means distance moved by object with time is 0. Okay, see the graph. Okay, this is the graph. Suppose this is the graph. Okay, so it is x-axis. It is x-axis, that is time, and it is y-axis, that is distance. Suppose this is distance is y-axis and time taken is x-axis, that is denoted with t and s. Okay, second, and distance is represented by m. Okay, so this is supposed time is starting from 0, 5 seconds, 10 seconds, 15 seconds, and 20 seconds. Okay, time is continued. But suppose object is starting from rest, that is 5 second, 5 meter, 10 meters, 15 meters, and 20 meters per second. Suppose the object, so here I already told you the distance moved by the object with time is 0. Okay, if a distance means if a object moves, means that will be with time, that will be 0. Okay, suppose, so we will take the line graph horizontally. Okay, the line will be drawn horizontally. Okay, this line is showing that object is at rest. Okay, object is at rest. Okay, with time. Okay, object is at rest. The distance covered by the object with time is 0. Okay, with time is 0. So that is why I drew a line that is horizontal. Okay. Okay, let's discuss another case of distance time graph, that is the object moving with constant speed. Means that object which is moving in constant speed. Okay, see here, the speed of an object is said to be constant if it covers equal distance an equal interval of times. Means whatever is the time, so that will be the distance covered. Okay, see the graph. So it is my vertical axis, or you can say it is called y-axis. It is distance, and x-axis is it is time. Okay, 0, 5, 10, 15, 20. Okay, 5 meters, 10 meters, 15 meters, and 20 meters. Suppose a car is covering 5 kilometers in 5 seconds. In other 5 minutes, it covers 5 kilometers in other 5 minutes. Okay, 5 seconds, sorry. In other 5 seconds, it covers 5 kilometers. In other 5 seconds, it covers 5 kilometers. Okay, this means the distance the object is covering equal distance and equal interval of time. So likewise, we will draw a straight line having these points. Okay, these points, make these points together and we will draw a straight line. Okay, so it is showing that object is moving with constant speed. Means it is taking the speed of an object is said to be constant if it covers equal distance and equal interval of time. See, if it is covering, a car is covering 5 kilometers in 5 seconds, another 5 kilometer in another 5 seconds, and another 5 kilometer in another 5 seconds. Okay, distance and time both are same. Okay. Okay, let's discuss another case, that is acceleration. Means the object is accelerating. Okay, means the object is increasing its speed. If the object is accelerating, then its speed increases and object covers more distance each seconds than the one before. Okay, see the graph here. Okay, it is saying that if the object is accelerating, it means its speed is increasing and the object covers more distance each second. Suppose in first 5 seconds it is covering 5 kilometers, and other 5 seconds it is covering 20 seconds. Means if the object is accelerating, then its speed is increasing and object covers more distance each second. So it's can say graph will be curved likewise. Okay, its graph will be curved likewise. This means the object is accelerating. If it is accelerating, then its speed is increasing. Okay. Okay, come to another case, that is, in this case the object is moving with variable speed. Means here the speed is not constant. Okay, the speed is changing in different places. Okay, if an object does not cover equal distance and equal interval of time, then the speed is variable. Means the speed is not same if the object doesn't cover equal distance and equal interval of time. See the graph here. So I will draw the graph. Okay, this is the graph. Suppose this is the graph. So it is my x-axis and it is y-axis. So it is my graph. So I will take a point where I am supposed to take out the speed. Okay, suppose I'm supposed to find out the speed of this point. Okay, so for that I will take a tangent. Okay, of this graph. What is tangent? Tangent is the line which touches the curved line. That curved line. Okay, curved line or that circle. So suppose this is the tangent. It is the line, tangent line. Okay, suppose this is the tangent line, and now I will take the distance here. Distance I am taking. Okay, see here, distance, I took the distance. Okay, likewise it will be, the line will be drawn from here. Okay, okay, now this point, I will give this point P, name P. Okay, this point Q, and this point R. Okay, so now I can easily find out the speed of this point. Okay, as you know, the speed is variable, that is not constant, it is changing, okay, place to place. Okay, now see here, this graph here, it is a shape like triangle, it is being drawn. Okay, shape like triangle, see here. So here, see here the point R, it is perpendicular, and here the point is, it is means it is horizontal, here it is time, and here it is perpendicular, that is distance. So now we can easily find out the speed. Okay, here it is, as I told you, this point that is perpendicular, it is distance, and this point that is horizontal, it is means time. Okay, okay, now we will take out the speed of point P. This is the point P. So R is the distance, R is the distance. Okay, QS is the time. So I will write R is my 30, that is 30, see here, and time is also yes here 30. So if you cancel out them, what remains? 1 meter, okay, per second. Okay,